Hello and welcome back to my little series that is modelling how to tackle some of these really challenging calculations that you might see in the quantitative chemistry topic at GCSE. So in this video we're going to look at how we can use the idea of moles in order to predict the reacting masses or predict how much product we can get from a particular reaction. So this is the question that we're going to look at today. We've got the equation for making iron oxide, and so this balance symbol equation is given for you at the top. Let's read through the question, and as always we need to bug the question as we go. 11.2 kilograms of iron was reacted with excess oxygen. So I'm going to put a circle around my number, 11.2 kilograms. And again, straight away I'm looking at that and thinking, I reckon we might have a little cheeky conversion to do here, because normally in chemistry we're working grams, but this is asking us, it's giving us the number in kilograms. We're going to underline the names of our chemicals. So iron was reacted with excess oxygen. That just means we've got more than enough oxygen that we need. We're not going to worry about the oxygen in this reaction because we've got plenty of it. So we just need to worry about the iron. Calculate the maximum mass of iron oxide that could be produced. So calculate is our command word. That's telling us we're going to need to do a calculation. The maximum mass of iron oxide, that's our product, that could be produced. Give your answer in grams. So I was right in thinking that we're going to need to do a cheeky little conversion at the start of this. And we've been given the relative atomic masses of iron and oxygen to help us. But remember, if you're not given those in a question, you can always find them on your periodic table by looking at the top number. And this question is worth 5 marks. So we're going to need to use the equation that we looked at last time that links together the mass of a substance, the number of moles of a substance, and its relative formula mass, what we abbreviate to the MR. So let's start off by dealing with that conversion, because that's going to be one of your 5 marks in this question. Okay, so you should know by now that there are 1,000 grams in a kilogram, so 11.2 kilograms will be 11,200 grams of iron. The next step is we're going to need to work out the number of moles of these substances, because we're going to be using the molar ratio. So the way I like to set this out is by putting down the 2 chemicals that we're going to be working with. So in this one, we're working with the iron, because we've got 11,200 grams of iron, and it's asking us to calculate the mass of iron oxide. So I'm just going to put the formula for iron oxide down here. So I'm just sort of picking out the key parts of the equation. We only need to worry about the iron. We only need to worry about the iron oxide. So let's put down what we know so far. Well, we know the mass of iron is 11,200 grams. We don't know the mass of iron oxide yet. Okay, so let's just put a little question mark underneath that, because that's what we've got to try and calculate. What else do we need to know? Well, in order to go from iron to iron oxide, we need to know how many moles of iron we have, and then that will help us work out the number of moles of iron oxide, and then we can work out the mass of iron oxide. But to do that, we need to know the MR, the relative formula mass, of both of these substances. So let's write that underneath our 2 substances. So MR, well, iron is just the atom by itself, so we just use the relative atomic mass, which is 56. For the iron oxide, we've got a little calculation that we need to do. We've got 2 lots of iron, so it'll be 56 plus 56. 3 lots of oxygen, so plus 16, plus 16, plus 16. And I'm going to do that on my calculator. 56 plus 56, and then plus 3 lots of 16. That gives us 160 for the MR. Okay. Now, we're going from the iron to the iron oxide because we know both the grams of the iron and the MR. So now, using our formula, we can work out the moles of iron, but we're going to need to do some rearranging. So remember, we need to divide both sides by the MR, divide by the MR. So that gives us the mass divided by the MR will equal the number of moles. So let's do that with the iron. So the number of moles of iron will equal, I'll just move my camera down a bit, will equal 11,200 divided by 56. So I'll just do that on my calculator, 11,200 divided by 56. That gives us 200 moles. Okay. Now, because we know the number of moles of iron, we can now work out the number of moles of iron oxide. However, to do that, we need to go back to our balance symbol equation, because you can see here we actually need 4 lots of iron, and that makes 2 lots of iron oxide. So the ratio of iron to iron oxide is 4 to 2, but we can simplify that to a 2 to 1 ratio, and because we're going from the iron to the iron oxide, that means we need to divide by 2. So the number of moles of iron, so 200 divided by 2, that gives us 100 moles. And now we're nearly there. We've got 100 moles of iron oxide. We know its relative formula mass is 160. So to work out the mass of iron oxide, we can just use the equation as we expressed it to start off with. Mass will equal the number of moles times the MR. The number of moles is 100. The MR was 160. So we just pop that into our calculator. 100 multiplied by 160. That gives us 16,000 grams as our final answer. Okay, so let's just go over the question and see where we would pick up these 5 marks. Well, in this example, you would get 1 mark for the conversion that we did at the start of kilograms into grams. You would get 1 mark for calculating the relative formula mass of iron oxide, which is 160. You would get 1 mark for calculating the number of moles of iron. You would get 1 mark for understanding the ratio was a 2 to 1 ratio, and therefore calculating the number of moles of iron oxide. And your final mark was the calculation of the mass, doing the moles multiplied by the MR to give you your answer. So there we have it. Quite a challenging question there, where we had to use the molar ratios and we had to use the mass equals moles times MR equation in order to calculate the predicted mass of our product. In the next video, we're going to be looking at how we can use this idea of moles to calculate the limiting reactant in a reaction. See you next time.